Hi guys, so in today's video we are going to graph the trigonometric functions. So we are getting away from trigonometric ratios. Right, ratios means we have a triangle and we are comparing the quantities, one length compared to the other length. So we are getting away from the ratios, and now we are thinking of them as functions. Right, so we have started that by our unit circle. So in the last video we did unit circle. Right, so we have started thinking of those ratios in terms of angles, because here the sine and cosine value, so that your x coordinate is always cos, your y coordinate is sine, and then it is subtended at an angle theta, right, between the positive x-axis and whichever angle you want. All right, so it's called terminal side. So terminal side and reference side. All right, so now what we are doing is we are going to graph the sine function first. So we'll start with the sine function. So we're going to graph sine functions using the values that we have already found in the unit circle. Right, so our first one here is, instead of x-axis and y-axis, so we are not using x-axis and y-axis, we will be using theta, right, and sine theta here, right, because we are using y is equals to sine theta. So here we have theta as our x-axis and y is the whole function, which is sine theta. All right, so using the unit circle, we know theta is 0. We know that sine is 0 as well, right, because there is y-axis, the y coordinate is 0 there. So that is our first point here. Then we do, let's do the main ones first. So then we do 90 degrees, right? At 90 degrees, we know that our y coordinate is 1 and our x coordinate is 0. Right, so it's 0. Sine is 1. So let us suppose that is 1 and minus 1. So here at pi over 2, which is 90 degree, our sine function is 1. All right, next we will be doing next we are going to do 180 degrees, right? 180 degrees. At 180 degrees, we know that the x-axis is minus 1, whereas y-axis is 0. That means at pi, which is 180 degrees, our sine value is 0. All right, then we do 270 degrees. Let's extend this line a little bit further. All right, so now let's do the next one, which is going to be 270 degrees, and 270 is 3 pi over 2, right? So that was 90 degrees, that was your 180 degrees, and now 270 degrees, just to make it clear. Now at 270 degrees, which is here, we know that our x value is 0, whereas y value is minus 1. So it is going to go down at minus 1, right? So it's gonna go down at minus 1. So minus 1 will come in here, right? And then the last one is 360, and 360 again is going to be 0. So our next one is 2 pi, which is 360 degrees, and then you go up to 0 again, right? So if we join the curve, here, we can get a beautiful sine curve. All right, cool. Mine is not that beautiful, but you get an idea of what I'm saying. All right, so now in the next part we are going to do the transformation of these sine functions, right? So hang in there. All right, so before we go to the transformations, so now that we have done the sine function, we have done how to create it and how unit circle is linked to it. Let's go in and see the transformations. So that is our normal sine curve, right? This normal sine curve have its turning points here at 90 degree. All right, so first turning point is at 90 degrees, or you can write at pi over 2, and that is a maxima. The minimum or the minima, or another turning point, is at 3 pi over 2, which is 270 degrees, right? So the turning point is happening every 180 degrees again, but it is starting at 90 degrees, right? So those are the turning points, and again there is a turning points here as well. All right, so that is a normal sine curve. Now in case we change the angle, so the angle is x or theta, so we change the angle to twice that angle, right? So we need to understand here that if it was like sine 60 degree, now sine 2 times 30, so 30 degree is doing the same thing what 60 degree was doing. That means the work is happening faster, right? So the cycle is going faster because now 30 degree is doing the same thing. So that means the red line here is our normal sine curve, whereas the blue one is the new transformation. So here we can see that if the blue line starts at 0, one whole circle finishes in 180 degree. So one whole circle is finishing in 180 degrees, right? So that means it is twice faster, right? Okay, so here we are going to use two new things, that is frequency and period. Okay, so frequency is how frequent is the thing happening. All right, so here the frequency is going to be twice. So the frequency here means how frequent is the thing happening, and this thing is happening twice in 360 degree, right? So it is happening 2 times in 360 degrees. So that means the frequency is 2, whereas the period means, period is how long is it taking, how long does one cycle takes, right? So one cycle here takes 180 degrees, all right? Or you can write pi. An easier way of finding it is 360 degree divided by the number you have in front of the angle. So that is going to be 360 divided by 2, which is 180 degree. All right, so we need to make sure that we know these two new terms, frequency and period, right? In your physics you use that word more. All right, so that was frequency or period. All right, another thing is when the angle become half. So that was when angle is doubled. Okay, now when the angle become half means it is slow, right? So it has slowed down. Okay, so slow down means now the one is going to take double the time. Okay, so the frequency here is half, right? Because in 360 degree it's only half of the curve that is going through, right? So the frequency is half, whereas the period is 2 times 360. So that is going to be 4 pi, because the circle is going to complete at 4 pi. Okay, so I hope this makes sense of frequency and period. All right, next one when we go to is when we subtract an angle. So there we were multiplying and dividing. So previously in the period and frequency we were multiplying or dividing the angle. Okay, now we are adding or subtracting. So when we subtract an angle, what happens? All right, so when we subtract an angle, it moves to either right side or the left side. So it moves either here or here. It's a subtraction. So subtraction means it will move towards the right side. Subtraction means it is moving to the right side. Okay, so here it has moved pi over 6, so it has moved 30 degrees. Okay, so here you can see it has moved 30 degrees to the right. If it was plus, it would move to the left hand side. Okay, so this has now moved to the left hand side. So it has moved. In this one we have 60 degrees, so it has moved 60 degrees to the left side. Plus means left side. Okay, and this moving is called shifting. Okay, so it's called a shift, and because it is shifting horizontally, it is called a horizontal shift. Okay, so this value here gives us the horizontal shift. Great. Now let's go to the next type. So the next type is when we add to the entire function. We are not adding just to the function, just to the angle. We are adding to the entire function. All right, so when we add to the entire function, from your previous graphs you might remember that this is y-intercept. All right, so y-intercept means it is going to change the y value of it, right? So if it is sine x plus 2, it is going up 2 points, and if it is sine x excuse me, minus 3, comes down. All right, so if it is just the number with the whole function which is added, this is again shifting. So this will now be called as vertical shift, because the whole curve, the whole function is shifting up, or the whole function is shifting down. It's not just the angle that is moving, it's the whole function which is going up and down. Okay, so that is vertical shift. Now the last bit that we are doing is stretching it. Okay, so now the original was sine x, which is shown with the red color. With the blue color you have 2/3 of sine x. All right, so we have reduced the whole function. We have reduced the whole function to its 2/3 value. Right, so we are shrinking it. If you can see, shrink. Okay, so you are shrinking it. So here if you could see the blue line, so blue line is shrinked or has a smaller amplitude. So that's the new word now, amplitude, because amplitude is how much wide it is horizontally. All right, so the amplitude here is usually from x-axis how much it's going up or how much it's going down. So for your normal curve it was 1, yeah, and for your blue one it is now smaller, it is 2/3 of 1, so it is 2/3, and the next one, the green one, is the bigger amplitude of 2, so it has gone wider. Right, so that is called amplitude. You can also call it vertical stretch. Okay, because we are stretching it or shrinking it. Usually we call it vertical stretch. Okay, and similarly if we go back to the angle one, we can have horizontal stretch as well. So this frequency, because we are stretching it again, this could be horizontal stretch. Okay, all right, now let's put all this together in one equation. Right, So now we have one equation. Before I do that, so we have now one equation, y is equals to a sine, okay, then you have bx plus c in bracket and then plus d. Okay, so we have just done that. If the number is in the front, okay, it multiplies the entire function, so that is your amplitude. Okay, that is your amplitude, or that was your vertical stretch. Okay, now when we multiply the angle here, that gives you horizon, that gives you frequency or period, and that is your horizontal stretch. And it just makes sense because it is the x, and x is our horizontal axis, so it is the horizontal stretch, whereas a is changing the y value, so that means it is the vertical stretch, right? Now c is moving the angle, all right, so c is moving the angle, means that is our horizontal shift, because it is shifting, moving it around. And this d works as our y-intercept, so that is our vertical shift. Okay, so these are a few new terms. Let's highlight them. So these are your few new terms to remember. Vertical, oops, that's not a good color, let's change the color. Right, so we have vertical stretch, we have horizontal stretch, horizontal shift, and vertical shift, right? And now let's see a graph, how it looks like. So here in this graph, we have the normal sine function, which is the red line. Okay, so we have a normal sine function, and I have shaped two curves, right? The only difference in that is in your green curve, you can see that this here sine of the angle, this is the whole angle. Half x minus pi over 6 is the whole angle, right? Whereas in the other one, it is half of only x. All right, so here the subtraction happens first, okay, and then you half it, and here it is the half of the angle first and then you subtract, right? And that is why there is a minor shift between the lines, right? There is a minor shift with the lines. All right, I hope that makes sense, right? So these are creating. Now I would like you to log into Desmos. So go into Desmos and play with a few equations which are on the booklet. Right? Hope this makes sense. If you have any questions, ask me in the class or put it in the comment section below. Great. Have a good day.